And Megan is going to present for us in the cloud a holistic approach towards GxP compliance.
All right, thank you so much, Julianne. And hello, everyone. Thank you all today for coming to this talk. My name is Megan, and I'm an R developer at Pharma with a background in life science research. I know folks have already presented on validating R code and R packages. This talk will not touch upon that. Rather, my talk will mostly be focusing on the troublesome aspects of creating a validation plan that ensures that the cloud platform running your R code is GxP compliant. Now, to give you some background on computer system validation. Traditionally, when things were run on-prem, a company's IT department would qualify and validate the infrastructure and the software. But now, as more services move to the cloud, you have third-party vendors who take some of that responsibility away from your IT department and your team. Music. Ooh, sorry. Anyways, if your IT department isn't already doing the security, operational, or performance qualification of the vendor system, these tests and procedures may be provided by the vendor for the company. As you can see in my very simplified diagram on the right, 50% of the validation plan still lies with your team. The vendor is responsible for proving that the platform has the capabilities to fulfill your intended use, but it is up to your team to define what that intended use is. And it is the stakeholders' job to make sure that their code or application functions on the cloud and that only the relevant parties can access the platform or service. All right. So there's been a big push to automate the configuration and deployment of systems. In my case, I'll be using Apache Spark as an example. You can now set up a Spark cluster using any one of these cloud vendors, be it Microsoft Azure via Databricks, or AWS EMR, or Google Cloud's Dataproc. And creating a cluster to your team specifications is easy. This can all be done through a JSON, YAML, or Terraform file. The best practice is to automate deployments and use these infrastructure as code files as a way to document cloud platforms, and IT teams certainly do so as part of their qualification or validation procedures. But what are situations where your scientists are running live sessions in the cloud where their analyses aren't automated? I will touch upon this point later in a scenario as an example. That didn't detract too much. Oh yeah, thank you, Julianne. All right, going back to the slide. So I have here a very general outline breaking down what's expected in a validation plan. Your validation plan is ultimately your manual that should comprehensively cover why your system is used, how your system will be used, how is data processed and or analyzed on the system, and how your teams will maintain the system, delimiting your team's scope versus the vendor scope. And I have here a little reminder of the difference between qualification versus validation. Qualification are steps that will be performed to ensure that the system is functioning as you intended. However, validation is the overall process of all sorts of qualification steps. All right, moving on. I'm not here to present a thorough guide on how to design a validation plan. However, my biggest take-home message to you will be that this document is your roadmap for how your cloud platform will be handled for the duration of the use. Your plan is not a one-and-done deal. You will have to periodically revisit various processes and a timeline you've set forth for yourself as detailed in the plan. Various reviews of processes can happen quarterly, semi-annually, or annually. It doesn't mean that you have to write out very stringent processes that will be extremely difficult to follow. But whatever you set forth in your plan must be followed, and you have to provide proof that you followed them. All right, and here I will be going through some scenarios showcasing problems with the validation plan or potential problems relating to the validation plan that may come back to haunt the team. Scenario 1. A validation plan is in place, but the user requirements and specifications are vague and the plan frequently cites other SOPs. So this is a very basic problem because so many protocols have been written up, people automatically assume that, oh, because I have something already in place that is applicable, I can just recycle the protocols and reference them. Citing pre-existing SOPs isn't a problem, but your plan is the place where everything is consolidated. And so effort should be made to make sure that your master plan is easy to understand without sending your auditor on a goose chase to comb through a number of documents and guess what your requirements are. And then after looking through all these different SOPs, relate those processes back to your validation plan. All right. And then scenario number 2, modifications to procedures or personnel are not consistently tracked. And the biggest problem here isn't that the changes aren't recorded, but rather that the minor parts to these major changes, such as, let's say you have all your major stakeholders clearly delimited in your plan, but years later, new departments are added and way more personnel gains access to your Spark cluster. As part of your process, every user needs to pass through some sort of training in order to gain permission to access the system, and the access permission is locked. But since there are so many different departments with different processes involved, you don't have a clear record of new users who were qualified by the training process. And then the final scenario, and in my opinion, this is the most problematic out of all the scenarios, is you have scientists or analysts already using the cloud platform, but not in a GxP context. And then all of a sudden, they now have to validate their environment to be GxP compliant. But the problem is, bad habits have already started forming because previously they didn't have to worry about GxP compliance. Validation plan dictates the protocol that users will follow, and you will most likely forget to follow them because you never had to previously. So, for example, a lead statistician whose team had used Spark in the cloud for well over a year, when they were using it in a non-GxP compliant manner, they didn't hold any code reviews. And in the lead statistician's mind, he or she does not care for code reviews because the idea seems redundant. So long as the code executed has been logged in the system and passes all the validation tests, why do they need to bother with a code walkthrough? But code reviews go hand in hand with validation testing. And the tests that determine your acceptance criteria are frequently derived from these reviews. Each R programmer cannot review their own code. Someone else has to review their code. And finally, this review is proof that an evaluation has occurred. It is part of the CI/CD and supports the overall validation process. A repo is not a requirement, but having a centralized repository helps with in facilitating this code review process. All right, ultimately blazing through. In summary, I think these 2 points encapsulates my messages very well, which is, for one, the validation master plan is an outline of processes, and all of these processes are continuous. There should be ongoing evaluations of not just the system, but also the code that is run on the system. And secondly, tiny mistakes pile up because they're not obvious. People tend to concentrate on major tasks, and the minor tasks fall to the wayside. But unfortunately, these tasks still need to be completed. And that concludes my presentation.